Welcome to Part B of Module 5, the data layer. In this section, we look at how we capture, process, and keep climate data. A climate consultant's work rests on a chain of data. If that chain breaks, the emission reductions or inventory figures are not safe. To understand this, we will trace a real metered device chain. We will go from a sensor reading to a reported figure. We use the verified example of metered cookstove monitoring, operated by gold standard. In this approach, sensors attached to stoves record actual usage. Emission reductions are computed from measured cooking events. They are not estimated from surveys. This shows the clear difference between an estimated and a metered indicator. This example helps us see how real data flows. Every measurement begins with a data source. Data sources exist in a strict hierarchy. Primary data is collected directly from the source or event. An example is a sensor reading on a cookstove. Another example is a direct measurement of fuel consumption. Secondary data is different. It is derived from existing records, published databases, or default factors. These factors are provided by recognized bodies. When building a measurement, reporting, and verification system, you must set a clear hierarchy. This hierarchy dictates when primary data is required. It also shows when secondary data is acceptable. You need to know exactly where your data comes from before you use it. A clear boundary between primary and secondary data helps you build trust in your results. It also makes your reporting much stronger. The most common failure point in any climate data system is the unique identifier. A unique identifier is a distinct code. You assign it to a specific data source, device, or transaction. This allows you to track it across different databases and processing stages. In our metered cookstove example, each stove must have a unique identifier. This links the physical device to its sensor. It also links to the sensor's data stream and the household it serves. If a sensor is replaced, the new sensor must map to the existing stove identifier. When unique identifiers are mismanaged, data streams become orphaned. An orphaned data stream is a set of readings that you cannot confidently link to a specific project activity. When verifiers encounter orphaned data, they must discount the associated emission reductions. This means you lose credit for your work. Data is captured using collection instruments. A collection instrument is any tool used to record data. It can range from an Internet of Things sensor to a structured survey questionnaire. In digital measurement, reporting, and verification, manual steps are replaced with technology. This is known as dMRV. It combines satellite imagery, artificial intelligence, IoT sensors, and distributed ledger or blockchain records. Regardless of the instrument, data must undergo validation at entry. Validation at entry is the process of checking incoming data against predefined rules. This happens before the data is accepted into the primary database. For a metered cookstove, validation rules might reject a reading. This could happen if the reading implies the stove was operational for more hours than exist in a day. It could also happen if the data format does not match the expected transmission protocol. Once data is captured and validated, it must be governed by version control and evidence retention. Version control is the practice of recording every change made to a dataset or calculation file. You must note who made the change, when it was made, and what the previous value was. Evidence retention is the policy of securely storing all raw data, calibration records, and calculation inputs. You keep these for the duration of the project and any mandated post-verification period. If a calculation methodology is updated, version control helps you. It ensures you can recreate the exact calculation state from any past reporting period. This is very relevant today. Existing projects are currently transitioning to the Paris Agreement crediting mechanism methodology for all vintages from 2026 onwards. This is a real rulebook change. It forces measurement, reporting, and verification systems to be respecified. The ultimate test of a data layer is the audit trail. An audit trail is a transparent, chronological record of all data and events. It allows an independent party to reconstruct a reported figure without the original analyst present. If a final report states a specific volume of emission reductions, a verifier must be able to trace it back. They trace it back through the calculation engine to find the raw sensor data. They verify the unique identifier of the device. They confirm the calibration records of that specific sensor. The World Bank's Carbon Markets Infrastructure Working Group produced a technical guidance note on standardizing digital MRV. This note includes evaluation criteria for assessing system performance. It shows what good looks like in a digital system. You should use these criteria to check your own work. A proper digital workflow runs in 6 steps. The first step is data capture. The second step is standardization. The third step is quality control. The fourth step is calculation. The fifth step is independent verification. The sixth step is registry issuance. A registry is an official database where carbon credits are issued and tracked. This digital workflow runs without manual re-entry between steps. It maintains continuous audit logs. Because of this, verifiers review structured data rather than reconstructing scattered records. This makes the verification process much faster and more reliable. The digital system keeps a clear record at every stage. This means you always know who did what and when they did it. The system holds all the evidence in one place. When you use these digital pipelines, you reduce the chance of human error. You also make it easier for auditors to check your work. However, technology does not eliminate error. A consultant must understand the documented failure modes of these technology categories. Sensor drift and calibration loss occur when a physical sensor's accuracy degrades over time. This causes it to report false values. Cloud cover and resolution limits in optical remote sensing can obscure satellite imagery. This creates gaps in data. Silent failure in automated data pipelines happens when a system stops recording or transmitting data. Crucially, this happens without triggering an error message. Furthermore, using a distributed ledger or blockchain does not fix bad data. An immutable ledger entry of a wrong number is still wrong. You must design monitoring plans that account for sensor maintenance. You need rules for data gap filling. You also need automated alerts for silent failures. These plans keep your data layer strong and honest. The robustness of this data layer is not merely a project-level concern. It scales up to national compliance requirements. Under the United Nations Framework Convention on Climate Change Enhanced Transparency Framework, countries submit reports. Parties to the Paris Agreement submit biennial transparency reports every 2 years. The first report was due on 31 December 2024. A biennial transparency report covers several things. It covers the National Inventory Report and progress towards the nationally determined contribution. It also covers policies and measures, climate change impacts, and adaptation. Finally, it covers capacity building needs. As of July 2026, a record 37 countries had presented first biennial transparency reports. They presented them at the third session of the Facilitative Multilateral Consideration of Progress, held during SB 64 in Bonn. The data layer supporting these national reports must be just as traceable as a single cookstove project. Standard bodies are also changing how they treat digital systems. The Global Carbon Council has established a dMRV solution provider approval procedure. This is described as a first in the voluntary carbon market. Under this procedure, a platform named Trace has become the first approved dMRV platform. It was developed by NextGreen. This platform received provisional approval under Track2 for a specific sectoral scope. This scope covers energy generation, transmission, distribution, and energy efficiency. The teaching point here is the approval procedure itself. It shows dMRV moving from a pilot to governed infrastructure. A standard body now defines tracks and sectoral scopes. It gives provisional approval so a platform's outputs can be relied on in issuance. This means digital data is now part of the formal rules. It is no longer just an experiment. In summary, the data layer is the mechanical foundation of all climate consulting work. You must enforce strict unique identifiers. You must validate data at entry. You must maintain rigorous version control. You must build an unbroken audit trail. By doing this, you ensure that every reported figure can withstand independent scrutiny. Now, to finish this module, you need to complete a practical task. Produce a data layer architecture diagram for a specified monitoring parameter. Trace the flow from the primary collection instrument through validation, calculation, and final reporting. Explicitly map the unique identifiers and evidence retention points at each stage. This diagram will show you understand how to build a strong and traceable data layer. It will prove you can connect the theory to a real working system.